Welcome, everyone, to the second keynote of AO Ventures. I'm here with Tom Wilson, who's a longtime builder and founder in the Arweave and AO ecosystem. Today, he's going to give us a presentation on MemeFrame and give us a tour of many features of AOS, AO, and the permaweb. Once again, if you guys have any questions, please feel free to ask them in the comments, and we're going to collect them all in the Q&A section, or you can even just write them straight in the Q&A section, and then we'll stay in the chat after the event and just answer them all live. And with that being said, I'm going to pass the mic to Tom and we can get started.
All right. Hey, everyone. Can everybody see my screen okay?
Yes.
Very cool. All right. Yeah, so what we're going to do is do a live coding demonstration and take a tour of Arweave and AO all inside AO. And hopefully it'll prompt lots of questions. I'm going to go through several bits of technology, and I may be go a little deep. So if there's something that I'm talking about and you don't know, feel free to ask a question and we'll cover it later. But pretty much everything is built off of the internet. So if you know HTML, CSS, and JavaScript, you should be pretty good. We do some Lua, which is a fun and friendly language and easy to learn. So you write Lua in AO. And what we're going to do is create a meme frame. And what is a meme frame? So we've got this little quest where we have a challenge out there for people who are onboarding to AO to build a meme frame where you come up with a meme and you create a token and you create the staking blueprint so that people can stake that token and then add a voting mechanism. And that voting mechanism allows your meme community to choose if a web page should be the main page of your meme group or not. So basically, we're going to go through setting that up and kind of tour Arweave, AO, and the permaweb. First thing we need to do is build a permaweb page. And what we're going to do is actually use a little demo tool I set up that's kind of a web version of the AO console. And we're going to use that to send a message to our default process. And that message is going to contain HTML. And as a result, since Arweave and AO and the permaweb with RIO gateways all tie together, that data in that message will actually render on the gateway as a web page. So I think you'll find this kind of fun, but there is many ways to upload websites and data on Arweave. This is just one to make the demo simple. So I've created two functions: a send HTML function that's going to send data of the HTML I type, and a spawn function. In this spawn function, we're going to actually spawn a process that will be our meme process. And that's going to have HTML that's going to be a application, and it'll do the swap for us with the process. So let's go ahead and get started. I've got a default process here. I'll just go ahead and disconnect and go to default and reconnect. And what I want to do is, notes up here, is send an HTML page. And I've got this little simple HTML page already written up. I'm just going to type .editor, and I'm going to just paste it in. Again, all this is calling the send HTML method, and it's passing a string, which is just the HTML page, and it's just showing a Skelepunk image. So let's go ahead and click load, and that's going to load that into our default AO process as a message. So I should be able to go to my inbox and grab the last message in the inbox and do ID. And what that will give me is the ID of that message. And since that ID is an Arweave ID, I can take that ID and go to Arweave, any gateway really, but arweave.net and add that ID. And there's my page, a really awesome Skelepunk. And got my name right there, which is pretty cool. Safe from the community did this for me. So I like the image a lot. It's pretty cool. But so that's our page. Now we need to create a meme frame process. So the next thing we want to do is actually uh, pull up the editor again and do a spawn. So we're going to pull up the editor and we're going to set our frame ID equal to that ID that we created, that message ID. And then we're going to call spawn frame, pass in the frame ID and some HTML text. And I'm just going to copy that here. And this is actually just a single HTML app that actually connects to AO Connect. So it connects to the AO network using AO Connect, and it uses dry run to actually request a message on our process. And it will request this get frame message. And then if it returns a result, then it's going to swap the iframe here with that URL and therefore swap the page, if you will. So very, very simple app. We're going to load that up. And now that we're spawning a process from our process, the actual owner of that process is this process. And I'm going to change the owner to my wallet so that I can control that process I just spawned. So to do that, I can look at my inbox most recent message and tags, and I can see that the process ID is right here, process. So what I'm going to do is I'm going to send a message to that process and tell it to change the owner of that process to my local owner. Now I'm just doing this just to show off spawn, how you can spawn within a process, but also to keep from like changing screens too often in the demo. So let's go ahead and send target, and this target will be this process property. So I'm going to grab my last message in the inbox and the process property, and then the action I'm going to send is eval. And eval is going to say whatever's in data, run that code if you're the owner. And since my process here, IRZ, is the owner, it will execute. So what I want it to execute is data equals, and with Lua, you can use these square brackets for strings instead of quotes. Just makes things a little bit more readable for me because I'm going to add quotes into this. So what I want to do is grab my wallet owner right here, and I'm going to paste that in. Then I'm going to close my data string, and I'm going to close my table, and I'm going to close my function call, which is right here. And then I'm going to press enter. And what that's going to do is that's going to send a message to this newly spun up process that's going to change the owner. So to verify that, I'm going to connect to this process as my wallet. So I'm going to open up another shell, and I'm going to use Othent. Othent's really cool. and it works great on Firefox and Chrome and Brave. The one thing you have to do is when you do connect with Othent is to turn the web um, uh, third-party cookies check off and allow that, and then you're in. Okay, so we're gonna put in our process ID that we want to connect to. Hit connect, and we're gonna just make sure we're the owner by sending in an eval. So anytime I type an expression in the console, I'm simply sending an eval message to the process. So I'm gonna just send 1+1, and if it returns 2, then I'm the owner. If it returns something else, then I'm not the owner. So great. We were able to transfer that process from the process that spun it up to my wallet. So now I can act as admin for this process. So I'm going to load a couple of blueprints because this meme frame process, we want to make it a token, and we want to enable people to stake their token and then do voting. So I'm going to load up some code to do that, and we can just do load blueprint token, and then we can do load blueprint staking. And these little Lua files are in the AOS repository. And at the end of my notes, it'll give you a link to the AOS repository where you can look at them. But what we can also look at is the handlers we created. So we can just type handlers.list, and loading these two blueprints loaded some handlers that we have here. We have our token handler, so we can get info, balances, we can transfer, we can mint as long as we're the owner, we can get the total supply, and then we have these staking ones, so we can stake, owners of the token can stake their balance and participate in voting. So we have balances for staking, we have staking stake, and we have unstake, and we have finalize. So that's all pretty cool. And let's see here, clear that. And another cool thing I wanted to show is that we can customize our prompt. So we can just say prompt equals function return. Let's just call this meme and in, and that prompt function will now just customize our prompt from AOS to, well, if I don't have an error. So we just do open, close parens, and that'll customize our prompt from AOS greater than to meme greater than. Pretty cool. And now we can load with the editor, and I'll go through this code a little bit more detail. So the gist of the meme frame logic is here on the meme frame repo, and it's here in code. And what we're going to do is load this through the editor, but I just wanted to walk through it really quick. Basically, what this does is it allows owners of your meme process token to submit proposals if they've staked that token, and then vote on those proposals. So here we have a get votes handler, which means anybody can come and request the get votes and see what votes are going on. We have get info, which will return information about this process. And then we have some handlers here to handle minting. So when I send AO cred from my wallet to this meme frame, it's going to receive a credit notice message. And if that credit notice message is from the buy token, which is AO cred, then it's going to mint me some tokens for this meme. And then it's got some logic to do a refund if it's above the balance, etc. But basically, I should see a successfully minted function. And then I have a vote. And basically, the vote function, the first time you start a vote with a vote ID, it's going to take that as a proposal. And then anyone else can send a yay or a nay to vote on that up until the block height deadline. And when the block height deadline is released, then it's going to swap the web page with the other web page. And then lastly, a finalize function that will finalize all the votes when the deadline is hit. Cool. And then the get frame function, that's the important function that the app that we publish will use to determine what the web page is that you want to display. So I'm just going to copy all of this to my clipboard, hopefully, and not create a mess. It's fun. Let's do this. Just copy it from my notes here. And then we're going to go to our meme process and pull up editor. And we're going to paste that in. And so basically, we've loaded the token and then the staking rules. And now we're loading our meme frame rules. And at this point, we should have a frame ID. And we've loaded all of our process logic. So if we go to our meme frame ID, which is up here, and open that on a gateway, we should see our web page that we created. Pretty cool. So basically, we opened this process on a gateway, and it ran the little app we uploaded, and it sent a message to AO to say, hey, what is the frame ID? And AO responded with a frame ID, and then it swapped its frame element with the ID, the TX ID that we provided earlier. So we are set up. Now we can start to, basically mint some meme tokens in exchange for AO cred. And then we can stake those tokens. And then we can create a proposal. And so I'm going to jump into my personal process here. And what we're going to do is we're going to set up a meme variable to our meme frame ID. So I'm just going to copy this ID really quickly. And what we're going to do is send some cred to this process. So we've got like 8 cred on this default process. So I'm going to do send. And then I'm going to do target equals cred and action equals transfer and quantity equals 1,000, which is 1 because the denomination is 3. So the 3 zeros are decimals. You can think of as 1.000. And then the recipient is going to be the meme. So we'll send this message to AO cred, and then AO cred is going to send me a message saying, I'm going to debit your account by 1 cred, and it's going to send a credit notice to our meme process and credit that account. So hopefully, if everything went well, we should get a successfully minted. Yay. And we can look on our process here for our meme frame, and we can see that it minted one meme token to my default address. Cool. So the next thing I want to do is stake tokens. So I'm going to use the send message again, and I'm going to set the target equal to cred, or actually to the meme. And I'm going to say action equals stake and quantity equals 1. And I want to set the unstake delay. And this is the delay of blocks until I can unstake my meme token to 1,000. So now that I do this, I'll send that. And what that's going to do is take my one, meme token and stake it. And now that it's staked, I can actually create proposals and vote. And basically, your voting weight in this meme frame is based on how many tokens you have. So if someone had 10 tokens and I had one, and they voted nay and I voted yay, then they would win and nothing would happen. But if they voted yay and I voted nay and they had 10, they would obviously win. So it's weighted based on whoever has what side has the most tokens when the vote kind of concludes. Okay, but before we make a proposal for a vote, we need to create another page for that proposal. So we're going to open up our editor, and we're going to call send HTML again, and literally took quite a lot of effort on these web pages. Just kidding. But literally, this web page is pretty much the same thing, but it's going to make the image spin. So that's my proposal. But what's fun about this, and there's several meme frame projects out there. One is Trunk, and they've iterated over time to add more functionality to their main page, and you can do a lot of neat stuff because essentially anyone in the community can build a web page, upload it to the permaweb, and if they've staked their Trunk token, they can propose a vote. So I'm going to load this up, and it's just going to make our image spin. And what we'll do is submit a proposal. So let's go ahead and submit a proposal, and we simply just send the vote action. So we'll do send target equals meme, action equals vote, and side equals yay. Because if you're submitting a proposal, why would you go to the effort of submitting it unless you're going to vote for it? So, and then the vote ID. So this vote ID is going to be the ID of the message that we just sent. So what I'm going to do is do inbox, the last message, and then .id. Okay, so we've sent that message to our meme process, and it's going to create a vote and show that I've voted. Now, let's see what our votes are. So we're going to send another message to the meme process and say action get votes. And there could be multiple votes going on at the same time. And obviously, they'll have different deadlines, and when they close, they can override each other. But, that's kind of the fun too. So we'll get the votes, and it's going to send it back in JSON because really the idea with get votes is that you would create a web page to show that. But if we want to kind of see that in a Lua table format, we can use require JSON and say decode, and then we can say inbox, our last inbox message, and data, and then that's going to decode that JSON into a Lua table and print it out for us. So you can see that our TX is this ID here, the deadline is there, and there's been one meme token vote for 1,000. So that deadline is approximately, I think, 24 hours. We're not going to wait that long. We're going to time travel and take this ID, and we're going to go into our meme process, and we're just going to change the frame ID, which when the vote concludes, if there's more yays than nays, this is what essentially the process would do. Would change the frame ID to the TX ID that's in the vote. And then if we go to our meme frame web page and refresh it, it should grab the new iframe, and we've got a spinning web page, which will make everyone dizzy if I keep showing this. But that's pretty cool. So that's a lot of interesting technologies there. I want to break down a couple of things. So as you think about AO and processes and messages, you may see the send command a lot. And the send command basically is a data item. And when you upload data into Arweave, you specify a data item. And what is a data item? So a data item is basically an ANS 104 specified item. And I've got a little note here that basically describes the data on chain sign. So it consists of the owner, a signature, an ID, which is a hash of the public key of the signature. I think I said that correctly. But you have an ID, and then you have a target, which is optional. We use target to identify the process we want to send the message to. And then the most important thing is you have metadata and your data, and we call the metadata tags, and they have they're essentially a collection of name value pairs. And what we do with the send function is we just add a little sugar to that. So when you specify any item on the table of the message that is not either target, data, owner, signature, any of these required fields, it's going to inject that before it sends it to Arweave into this tags array and take the key and add that as the name property and the value, and it's got to be a string, but it'll add the value as the value property. So that's where we get when we do a send or a spawn. This object here is just like a really simple looking data item. And so I can add multiple tags, or I can add tags at the higher object level, and it's just going to add those tags in there when it sends it to the messaging unit, which is then going to sign it, and send it to the scheduling unit that's going to bundle it and attest it for the compute unit to grab it and process it for that given process. So super important to understand the data item. One of the other things that's important to understand is GraphQL. GraphQL, so how you specify these tags in this metadata, basically turns GraphQL into a nice query engine for your messages. So you can query and look up any message using the tags as your filters to filter and determine what's going on. So that's kind of cool. And then the last thing that I wanted to kind of run through. Um, that's not directly related to this presentation, but I think is something that obviously we need to document better. But want to talk through handlers. And handlers in AOS is kind of like a programmatic case statement. So basically, when you send a message in AOS, it gets passed in to this handler's um, uh, pipeline is the best way to describe it. And so the message comes in, and if you can imagine, each one of these handle um, uh, objects are in a stack. And when the message comes in, it calls the first one, and each handle message has a name, a pattern matching function, and the handle function. The pattern matching function tells the evaluator whether it should call the handle function or not. So when you see handlers.add and you give it a name, the name is so that we can list the handler. So we can say handlers.list, and we can look at them and see which handler is in what order. So it's going to print out our handlers here, and we can see here we've got two internal handlers for eval and default. But if we go to our meme frame process and print out those handlers, there's going to be a lot more. Like we looked at the token handlers and the staking handlers, and then we'll have our custom handlers. And if you look at the custom code for the meme frame, you'll see those handlers getting prepended instead of added. So what they do when they get prepended, they go to the top of the stack. So the first handler on this meme process is get frame. So when you pass a message, it's going to come into this handler, and it's going to run this pattern function. And if that pattern function returns a true, it's going to run this handle function and pass the message to it. If it returns a false, it's going to exit and go to the next one. Now there's a third thing that it can return, which is a continue. And if it returns a continue, which is a string, so it can either be a Boolean or a literal continue, no other string, but a continue, it's going to execute that handle function, but still continue down the stack. So with this example here, we have this tick example. We're adding this, and then every time a message comes into this handler, it's going to call this pattern function, which is going to return continue, which means it's going to tell the process to send every message that comes down this way to this function. And it could do stuff. It could grab the time set stamp and set the current time, or do whatever you want to do. But that's super important. And what can get confusing is if you add this tick at the bottom. So if I add that all the way at the bottom here, and if any of these functions get handled and say true, then it's just going to exit out, and it will never call that tick function. So if you have functions that you want to call multiple times, you may want to consider using the prepend function versus the add function. But that's a great thing to do, is look at this meme frame repo and see how it's put together, because there's also this finalize function that needs to go after the staking function, right? So this finalize needs to go after the staking function. And we also have these before and after helper functions. So you can say after staking, and then it's going to return an object with an add. So you can say after staking dot add, and then add your handler. Or you can say before. Now, one thing to keep in mind though is once it's in there, it's in there. So if you want to change the position of it, the easiest way to do it is to remove it and then add it. And if you set up your code where it's item potent, so it'll only update when things are changed, then you can just reload your code in as you make changes. So if I have a function here, create, well, let's just go to my personal process, be easier, and say add a handle function in handlers dot add hello, and we'll just have a well, let's do this. We'll use the handlers util, so we'll say handlers utils dot has matching data hi, and that's our pattern function. And then we'll add a function for the message, and what we're just going to do is print someone said hi, right? And we'll do end and then close parens. So we added that handle function. And let's say, we wanted to change someone said hi to something else. So what we can do is just call add again. And let's just say someone said hi, and make the change and reload it. So you can save your Lua files in your GitHub repo, VS Code, protocol land, wherever, and then you can just say load, hello.lua, and it will load that file up. And then if you make changes, you just call load hello Lua again, and it'll load your changes. And the only thing you want to do is if you're assigning, kind of constants or globals that can change as it interacts, is basically just do a check. So you would do, foo equals foo or hello, right? So you would just save those variables like that. So then that way, anytime you reload it, if foo was already changed, it would just keep its state of what it was changed to, but then it will take your changes. So that's handlers, and there's a bunch of other neat stuff in Lua and AOS. Encourage you to look at the docs and ask a bunch of questions. We are in testnet, so things are constantly moving. But in this speaker notes, I put links to the cookbook and to the GitHub repos and to the Discord. But since you guys are all in AO Ventures, I'm sure you all have access to all that. And yeah, I hope you enjoyed this. This is super fun. I really love this demo because it touches pretty much all the pieces of Arweave at a very high level. And there's a lot of moving parts in there. So I encourage you to try this demo, and let me know how you do. If you get stuck, or who knows, maybe create a meme frame and do the quest and enter for the meme championship and get some AO cred, and have some fun. I know some community members have been having a lot of fun with Trunk and other memes in the community. So yeah, let's see what we create. So with that, I'll stop sharing and be happy to answer any questions.
Amazing. Thank you, Tom. I appreciate how in-depth all of that was. It looks like we just got one question right now. Also, Feel free to ask any questions that may not necessarily be related to the presentation. We got Tom here, so he knows a lot about the Arweave and AO ecosystem. So feel free to ask any questions. I know we answered a lot in some of the previous technical workshops. So um, I'll start with the first question here, and then we'll just wait 1 or 2 minutes and see if we have any others. But Tom, the first question is, can you load multiple Lua files into a single process? The handlers are clearly like public functions. Can you have classes in Lua, or would one process be an independent class?
Yeah, so the first part you can load multiple files. So if you install AOS using npm and Node, you can essentially create files in your editor of choice and require those files. So if you create a file foo.lua and you wanted to use it, you just would type local foo equals require dot foo.lua in your main.lua process. And when you say load main.lua, it will, courtesy of Community Labs, Martin, and founder of Bark's pull request, it will find all the dependencies and load them in for you. So yeah, pretty cool. Um, so that's the first part of the question. What was the second part again?
The second part of the question was, the handlers are clearly public functions. Can you have classes in Lua, or would one process be an independent class?
Yeah. So Lua has some interesting things. So basically, it has this table object that can be both an array or an object, and there's an interesting pattern called a meta table, and you can actually see an example of this in the AOS repo, which was done by another contributor, Bob from the RIO team, and it's called CredUtils. And here he creates a meta table, which is very, very similar to what you may find as a class in JavaScript or something. And basically, when you build this table, you use underscores to reference things, and then you can just do, um, cred.balance or cred.update, and it will call these meta functions. So you can really do some interesting things. Another note, too, Lua also has closures, which allows you to do a lot of functional programming if you're used to doing functional programming. And I encourage you to check out this utils Lua file, which has some pretty cool functional methods in there if you really like to write, kind of functional base code. So you have curry, concat, reduce, map, filter, keys, bind, reverse, compose, all kinds of good stuff. So a lot of fun, and that's a great question. I think classes are super valuable. Also, functional patterns are super valuable as well.
Great. Looks like we got a couple more questions that have come in. So thanks, Tom. That's really cool and fun. Is everything stored permanently? That's not always required. In terms of the long retention periods that organizations are legally obligated to comply with under GDPR, what about the recently announced native temporary storage on Arweave/AO?
Yeah, so AO's messages are all stored permanently. They're all Arweave transactions. So again, part of AO is to be able to run in a decentralized environment. In order to do that, everything has to be deterministic. And if I have a compute unit on my desk and someone else has a compute unit in China, we should be able to point to the same process and the same message ID and get the same result. And in order to do that, we have to store things permanently. With that said, AO can provide the business logic, if you will, for the temporary storage marketplace. So I'm not 100% super familiar with it, but it is a place where you would pay at an interval to keep things stored, and vendors would agree to store with you. Um, so that's something that can definitely work really well with AO. The business logic runs on AO, but we would probably not put messages there that need to be processed, because that data could go away. And then 200 years in the future, we can't replicate the same state. And that violates one of our principles with the AO network and Arweave.
Right. And is there any info on an NFT Lua contract that works with AO?
Yes, so it's coming very soon. We have a few folks that are working on this, and I think after shout out, there's an AO Summit May 15th in Charleston. If you can be there, I hope you can make it. It's going to be a lot of fun. But I imagine at the end of that week, we're going to have some answers for the community on some guidance on atomic assets. And the Bazaar team have been working really hard to port Bazaar to AO, and they're very close. So really, really excited to see the next chapter of atomic assets and how that works with AO, because I think that's obviously a huge a huge use case with Arweave, the ability to store NFTs permanently and know that they can't change. So very excited to see that move over into AO, to be a part of that use case.
That is exciting. I wasn't aware of that. I'm excited for that announcement. Um, and it seems that for now, the only way to interact with AO is through the command line. How could we connect AO to an iOS app?
Yeah. So with AO Connect is a JavaScript library, but all of the endpoints on the network are pure HTTP, and people have written a Go library for AO Connect. I imagine others in the community will write Rust or even AOS. All of the calls to send messages are essentially web requests and web responses. So if your framework of choice can talk to the internet, it can talk with AO. The only other kind of caveat is that you need to sign your messages using the Arweave signatures. And recently, there was a pull request to support Solana signatures as well as Ethereum signatures. So you can sign with Solana wallets and Ethereum wallets if you have their SDKs in your platform, and you can send them to AO and they will work just like any other message. So even though we don't have like a really nice slick guide, we have all the foundational elements. And if any iOS developer or Android developer wants to talk about potentially creating a library, happy to talk with them, and happy to make that a quest or bounty, because I think that would be very cool.
Nice. And what's the best way to find a list of Lua packages or libraries which AO supports?
Yeah. So the best way to find Lua packages is a package management system called Lua Rocks. And right now, AOS supports pretty much any pure package that's deterministic. And there's just not a great way to go through all of those packages and say, oh, this is deterministic or not. What I do is I pull them down and I look at the code, and pretty much if they're not hitting the file system, if they're not hitting the internet, then I'll give it a try and try it with a AOS process, and pretty quickly find out if it's going to do what, if it's going to work or not. Um, that's going to improve in the future. And I think there's community members that are working with the potential of other languages than just Lua to be on AO. AO certainly can support any language. We really found that Lua was something, and we're finding that even people that don't know how to code can spin up a process and communicate and get in there and chat. So it's just a really really fun way to you know remove some friction in Web3 to get stuff on chain. I don't. I'm biased, of course, but I don't think there's an easier way to get data on chain than AOS.
And this next question is a follow-up to the first question. So the first question was about loading multiple Lua files into a single process. And this question is, can you talk about how it handles handler naming conflicts when two Lua files have the same names for their handlers?
Yep, that's a great question. So if you noticed in the staking one, it had like staking dot balances as the name. So you can namespace your names to handle that. But if it is the same name, last one wins, right? So if you have hello and then you load another file that has a handler called hello, the last one loaded is going to win.
Nice. And when AO comes out of testnet and into mainnet, if a year down the line I spin up a node, would it mean my node needs to rerun all the processes since the initial launch of AO, or does it just pick up from the current state of the network?
Yeah, that's a great question. So what happens is, and again, it's in the spec, but the spec is probably not the best reading material. It covers a lot of ground, but it's definitely guaranteed to put you to sleep on some of it. But there's a spec called the checkpoint, and in the compute unit, there's logic to write checkpoints, and what it does is stores the memory to Arweave at incremental points. And one of the points is when a coup restarts, it takes a checkpoint and stores it. So then when it comes back up, it looks for that checkpoint. In the future, again, there's a whole lot of a security model coming out and payments model coming out, which will answer these questions. But in the future, as a coup comes up, if it's determined to trust that process, it can just pull the most recent checkpoint that was done and essentially resume that process to its most recent state, and then replay any messages that were created since that checkpoint. So the answer is no, you shouldn't have to reload all those messages if there's checkpoints on Arweave, and if you're, you know, and basically they're running every time either there's a busy season and they're getting stored, or it's being the coups are being shut down and restarted. So you should ideally you can kind of think of your process when you launch your process that it's never off. It's always on, because the next time you call it, it's going to go to its most recent checkpoint and evaluate any messages from there, which should be very short, and then give you access pretty quickly. So great question. And obviously, we're making a lot of improvements to the infrastructure, but that's the ideal state, is that 30 years from now, I can go in and open this meme frame and it'll be right where I left off.
Amazing. I think that that's all the questions. Um, Thank you, Tom, once again. Thank you for all the work that you do in the ecosystem. And thank you, everybody else, for being here. Make sure to tune in next week where we're going to do the last technical workshop with Lorimer. And then we're also going to do a presentation with Martin. And that one is actually going to be an hour earlier than we usually do. So it'll be at 2:30 p.m. Eastern Standard Time. And then, Tom, I think that you're going to come back on at some point later in the program. So, guys, get excited for that. And yes, once again, thank you, everyone. Thank you, Tom. And we'll see you guys next week. Bye, guys.